Okay, so today we will start with homogeneous differential equations. So let us come to this term homogeneous. What does homogeneous mean? There is a concept of homogeneous function that we need to learn first. Homogeneous functions. Suppose you have a function of x and y, two variables. Any expression of x and y. Suppose this x is cubed plus 3x square y plus yp. Now you see one thing. All the terms here are having the degree 3. The first term is x cubed, 3 degree term. The second term is 3x square y. Now x square is 2 degree and y is 1 degree. So the total degree of the term is 3. In the same way, it's y cubed. So it's again a 3 degree term. So all the terms in this expression are of degree 3. So if you are having an expression of this type, where all the terms are having the same degree, then we call this type of terms, this type of functions as homogeneous functions. But every time it is not possible to see like this. So what we will do? We will try to check it like this. You take the highest power of x common. Here it is x cubed. So what you are getting? The first term is 1. The second term you see, it's y by x. So that means if you take this x cubed common, you can write the expression as a function of y by x. So this x cubed into, you can say it is some function of y by x. Okay. If you can do this thing, then the function is called homogeneous function. If f of xy can be written like this, x cubed into some function of y by x. Here this function 1 plus 3y by x plus 3y by x whole cube, that function we are denoting as phi. We can write this thing where phi t is equals to 1 plus 3t plus t cube. Means if you replace t with phi y by x, then you will get this thing. So phi is actually this function. So this is the definition for homogeneous function, that if f of xy, a function of x and y, can be written like this, then it is called homogeneous, and of homogeneous function of degree 3. And where from this 3 is coming? This is the 3. The highest power of x that you are taking common, that power is called the degree of homogeneity. It's a homogeneous function of degree 3. So what we will have in our differential equations is that homogeneous function, these homogeneous functions. So mostly you will be looking at the homogeneous equation like this. Say dy dx equal to f of xy. This was the general form for first order first degree differential equation. And what we will see here, that this f of xy can be written like this phi of y by x. And this is the reason we call this type of differential equations as homogeneous equations. We can write the right hand side as a function of y by x. So one thing you see, if you are having something like this, 1 plus cy by x plus y by x whole cube, you are not being able to separate the variables. Because only one thing we have learned till now, and also I have said that In every process, ultimately you have to separate the variables. But here you see, if this is the expression that dy dx equal to this part inside the bracket, you cannot separate x and y. So there should be a way to separate these variables. So that we are going to do here now. So whenever you can see the right hand side, you are having a function of y by x. You take this y by x as some other variable, and whatever you are taking, that b or any other symbol, that should be a function of x also, because v you are saying as y by x. Usually we will see in the solutions that y is equal to function of x. This is the form of the solution. So both the terms here are functions of x. So v is a function of x. Why I am saying that? Is it so much important? Yes, because after taking this substitution, you have to change the differential term. This is the main reason. So you should know whose function is v, x or y or what. So v is a function of x. So when you are differentiating it, it should be dv dx. Very simple. So the differential equation will be given like this: dy dx equals to f of xy. There will be some expression of xy. From that, you need to convert it into y by x, some function of y by x. And then you have to take this y by x as v. You have to replace this thing. So when you are taking y by x equals to v, you can write y equal to vx. And now we have to change the differential, just like in case of that reduction to separable form that we have done, that ax plus by plus c equal to z. Just like that, we have to again differentiate both the sides and find the value of dy dx. So let us see. Differentiating, we can write dy dx. Now you will see that v is a function of x. So in the right hand side, we are having a product of two functions. So we can say it is, we are keeping x fixed, dv dx, plus then v is fixed, dx dx. So it's 1. So let me write it here. So it is x dv dx plus v. And if this is the thing, now we can easily substitute this value of dy dx in the differential equation. So if we do that, what you are getting, you can put x dv dx plus v is equals to this phi of v now. X dv dx plus v is equals to phi of v, because that y by x can be replaced with v. So that means you can write this equation like this. Now you see, the right hand side is a whole function of v. No x, no y are there. Only one variable v is there. And the right hand side, the left hand side is also a product of x and dv dx. So now we can separate the values. So we can write dv by phi of v minus v is equals to dx by x. So the variables are separated. Now we can easily integrate both the sides and find the answer. So next we are coming to some problems. Number 1, x square plus y square into dx minus 2xy dy equals to 0. And it is given that y of 1 equals to 0. Y of 1 equals to 0 means y equals to 0 when x equals to 1. This means y equals to 0 when x is equals to 1. So first of all, dy dx equals to f of x by this form. So see, this can be written like this, and then you take dx in the denominator, so dy dx equals to x square plus y square by 2xy. So this is dy dx equals to f of xy. This right hand side, x square plus y square by 2xy. It is f of xy. So we need to convert it into some function of y by x. So for that, we are doing the same thing that we have done for homogeneous function. We have to take the highest power of x common. Okay, so from the numerator, if we take the highest power of x common, you see it is, or you can do another thing. You can divide by the highest power of x in the numerator and denominator. It is the same meaning. Taking x highest power common and dividing by the highest power of x in the numerator and denominator, it is the same thing. So you can write it like this: x square plus y square divided by x square whole divided by 2xy divided by x square. So then you can just split it out in two terms. So it is 1 plus y by x whole square you can write, and in the denominator, if 1x is cancelled out, you can write it 2 into y by x. So see, it is a function of y by x in the right hand side. There are no other variables, only y by x is there. So in this step, you have to substitute y by x is equals to v, and taking x in the right hand side, you can differentiate differentiating what you are getting. Dy dx is equals to x dv dx plus v every time. Dy dx is equals to x dv dx plus v. Okay, so now this value we are putting in the equation. So x dv dx plus v equals to this 1 plus v square divided by 2v. X dv dx plus v equals to 1 plus v square by 2v. And now you change the sides of v. X dv dx equal to 1 plus v square by 2v minus v. So then 1 plus v square minus 2v square divided by 2v. So you are getting 1 minus v square by 2v. So now you separate the variables. So it is 2v dv divided by 1 minus v square is equals to dx by x. And now you integrate both the sides. So what you are getting? Integration 2v dv by 1 minus v square is equals to integration dx by x. So Next, we have to integrate. So how we can integrate this? 1 minus b square equals to t. So let 1 minus b square equal to t. Then this minus 2b dv will be dt. So when you are putting it here, it should be minus dt by t, and it is dx by x. So it is minus log t is equals to log x plus, say, I'm taking log c. So that means log x t c equals to 0. And remember, log x t c means log x t c equals to 0. Log something equal to 0 means that something should be 1, not 0. Now you need to put the value of t. So first of all, t is 1 minus b square. Then again, v is 1 minus y square by x square. So basically you are getting x minus y square by x. This. I think I have done again wrong. It is 1 here, sorry. This is 1, this is 1. So this is the solution. See if there is any question. Till now. But see, the question is not complete yet. We have not used that given condition, y1 equals to 0. That means y0 equals to y equals to 0 when x equals to 1. So why we need that? If you remember, while doing the chapter, we have said that this c is an integrating constant. It is an unknown constant. And the presence of this c means the solution is a general solution. That means it is presenting all possible solutions at once. So when you have this c, first you should put some condition on this, and then you can get the value of this c. You can get the value of c for some particular solution. So here we are doing that. We are putting y equals to 0 when x equals to 1. So if you put this here, it is simply c equals to 1. So you are putting back c equals to 1 in the equation, and you are getting something like this. X minus y square by x equals to 1. If you do the LCM, you will be getting x square minus y square equal to x. So this solution, x square minus y square equal to x, it is a particular solution, and including that c is the general solution. So this is how we are solving this homogeneous differential equation. Every time the same thing you have to do. Just you have to see whether after taking in this form, the right hand side is coming in a proper form or not. Whether you can convert it into y by x, a function of y by x. If you can, that means it is a homogeneous equation, and the rest you can do. So let us try another problem. Take the notes of this. So next we are taking this one. X dy minus y dx is equals to 2 root over of y square minus x square dx. No given conditions are there, so this much we have. So first of all, the same thing, try to convert into that form, dy dx equals to f of xy. So for that we are taking dx in one side, so y plus 2 root over of y square minus x square whole into dx. This we can write, and then you are changing sides of dx. So dy dx equals to this thing divided by x, so y plus 2 square root of y square minus x square whole divided by x. So when you are splitting this function, you see we are having that thing. So we can split it as y by x plus 2 into y square minus x square by x. And we can take this x inside the square root and we can write y by x plus 2 y square by x square minus 1. Because when you are taking that x inside the square root, it will be x square there. So now it is completely a function of y by x. So we can replace it. So let y equals to dx. So differentiating, what we are getting, dy dx equals to x dv dx plus v. Put it in the equation and you are getting x dv dx plus v equals to v plus 2 square root of v square minus 1. And so this can be cancelled out. So now you see it's dv by this root over of v square minus 1 is equals to 2 dx by x. So the variables are separated. We can integrate. So integrating both sides, we can write integral dv by square root of v square minus 1 is equals to 2 dx by x. Now this formula dv by v square root over v square minus 1 we don't know. Let me just once tell this. dv by square root of v square minus 1, or in general for say I'm saying for x, dx by root over of x square minus 1. This is log of x plus x square minus 1 plus c. This is the integration formula that we are applying here. Simply implies it is log v plus root over of v square minus 1 is equals to 2 log x plus, again I'm taking log c because all the values are coming with log. So from here we can put the value of b. That means log of y by x plus root over of y square by x square minus 1 is equals to this. We can write as log x square. That 2 is coming to the power of x. Then plus c. So here we can write it as log of y plus, you see, if I do the LCM, it should be y square minus x square divided by x. And here it is log x square into c that we can write. And finally, this logs can be removed from both the sides, and it should be y plus root over of y square minus x square equal to, divided by x equal to x square c. And then you take that x in the right hand side, so y plus square root of y square minus x square equal to x cube into c. So this is the general solution. So this is all about homogeneous differential equations.